Welcome. We have an EKWB EK Quantum Vector 2 nickel and plexi water block for an ASUS TUF GeForce RTX 4080. In this episode, we will unbox the EK Quantum water block and then install it onto an RTX 4080 TUF PCB. We will then install the card in our test system, fill the custom loop, and perform testing to obtain thermal, power, acoustic, and performance results. We will also lower and raise the power limit, undervolt and overclock the card. This is the Vector Network, and let's begin. The EKWB EK Quantum Vector 2 DRGB nickel and plexi water block actively cools the GPU, memory, and power stages. What's in the box is a mounting mechanism box and accessories box. Also, the Vector 2 water block with the metal backplate attached. Let's go ahead and remove the water block and backplate from the plastic bag. The EKWB Vector 2 GPU water block uses an acetal terminal attached directly to an 11mm thick copper cold plate. Before installation, let's add some plugs to the terminal on the front and also on the back. The installation begins by first removing the backplate from the water block. On the backplate, there are 7 Phillips head pre-installed captive screws. Do not unscrew these all the way. They each come with a metal spacer. If removed, the spacer is required to be screwed back. Remove the cardboard PCB. Let's grab out the I/O bracket and also the screws from the accessories box. 2 Torx screws secure the I/O bracket to the water block. Let's grab the thermal pads. Included are pads with 2mm and 1mm thickness. Let's cut the thermal pads to size and place them on the PCB, and making sure to peel the plastic film off both sides. Next, let's apply Noctua NT-H2 thermal paste, and then we can drop the PCB right on top of the water block. Next, let's secure the I/O bracket using the 5 Phillips head screws from the TUF RTX 4080 teardown. Let's place the 7 plastic washers onto the PCB. Then, we have 7 Phillips screws to secure. The 4 around the GPU processor are screwed in a crisscross pattern to apply pressure more evenly. Next, let's cut the thermal pads to size and place them on the back of the PCB, making sure to peel the plastic film off both sides. Then we can place the backplate on the PCB and secure it with the previously unscrewed 7 Phillips head captive backplate screws. The EK Quantum Vector 2 cold plate is CNC machined out of copper, which is then nickel plated, and the top is CNC machined out of cast acrylic. A single O-ring design is used to create a seal between the cold plate and the water block top. The water block is intended to have low hydraulic flow restriction, potentially providing performance even when paired with pumps running at lower end speeds. Click on the link in the top right hand corner for RTX 4090 Founders Edition unboxing, thermal testing, and a teardown with full cooler disassembly. The black anodized backplate has an L-shaped profile that reaches the base of the water block. This encloses the GPU and also increases the surface area, providing passive cooling to the backside of the PCB's core, memory, and VRM sections. Tactile magnetic covers are used to conceal the terminal screws. These can be removed, which allows for rotation of the branding when and if needed. Let's add 2 Corsair 90-degree adapters and 2 Coolant quick disconnect male fittings. Drop it in our AM5 test system and attach the quick disconnect fittings. Let's use Aqua Computer Double Protect Ultra Coolant in green. Click on the link in the top right corner for the ASUS TUF RTX 4080 thermals and teardown video. Stay tuned as the fill, followed by the testing, is coming up right now. The EK Quantum Vector 2 water block is based on an open split flow design, where the asymmetrical shape of the jet insert helps distribute an even flow between the copper fins. The fin structure geometry provides an even flow distribution and achieves a symmetrical flow by utilizing an internal bridge to secondary components. To obtain the results, 3D Mark Speedway stress test was run on an open-air test bench with ambient room temperatures at 21 degrees Celsius. For 100% power limit stock thermals, the GPU core temperature rose 23 degrees Celsius from an idle 28 to 51 degrees Celsius under load. The GPU memory temperature rose 24 degrees Celsius from an idle 32 to 56 degrees Celsius under load. Lowering the power limit to 70%, the GPU core and memory temperatures were 8 and 4 degrees Celsius lower respectively compared to 100% power limit. Undervolting the core to 0.95 millivolts and adding 135 MHz to the core to arrive at a targeted 2730 MHz core clock The GPU core and memory temperatures were 6 and 2 degrees Celsius lower respectively compared to 100% power limit. The overclocked model has a 2625 MHz core clock speed. Matching that by adding 90 MHz to the core, the GPU core and memory temperatures were each 1 degree Celsius higher compared to 100% power limit. Overclocking by increasing the power limit to 110%, adding 120 MHz to the core and 600 MHz to the memory clock, the GPU core and memory temperatures were 2 and 3 degrees Celsius higher, respectively, compared to 100% power limit. The 100% power limit is at 320 watts. Undervolting the card reduces the wattage from approximately 317 at 99% to 253 at 79%, a 64 watt or 20% reduction. This is comparable to the reduction in wattage at stock voltage but limited to 80% power limit. Frames per second was recorded during 3D Mark Speedway stress test. As stock, the FPS was 71 and at 80% power limit, the FPS was 70, a 1 FPS or 1% reduction. Stay tuned for upcoming episodes as the plan is to install this EKWB EK Quantum Vector 2 water block, backplate, and ASUS TUF GeForce RTX 4080 combo in a custom loop water-cooled PC build. Like the video by clicking the like button. If this is your first time here, go ahead and subscribe to the channel. This is the Vector Network. Please click on the bell for a notification when the next episode airs. Click on the links here for more videos like this, including video card and water cooling component teardowns, unboxings, and thermal testing for water-cooled PC builds. Thank you, and I'll see you at the next episode.